All right, thank you everyone for coming for this last session of today. I'm Sergei Shutov from Banksia Global, Managing Director of InterSystems Professional Services Partner. And today, together with my colleagues from InterSystems and Herman from South African office, we are going to talk about AI agents and InterSystems IRIS. Before we start, let's talk about what the AI agents are, because this is a relatively new concept. Different people mean different things when they are talking about AI agents. And if you have been to our workshop yesterday, you probably have seen the slides, but I don't have too many funny horse pictures, so we will go through them once again. One of ways looking into AI agents is like the secret agents or like the professional services agency, and pretty much the idea is you tell them what to do and you don't ask questions. You don't you don't really guide them. They have some some leeway, some agency and some autonomy on their decisions and things they can do. So in the context of AI agents, what are the things that they are doing? They can be split into two categories. The first one is getting information about the context around the query that they get. So they can query some databases, they can read the files on your local file system, they can search the internet on your behalf. Some of agentic tools can actually use your screen and mouse to manipulate operation system windows. So this is when we grab additional information and context of your query. And then on the other side, we can perform actions. So we can modify databases, perform API calls, execute comments on your behalf in your terminal, and do things like that. Another way of looking into AI agents is this one. This is a horse dancing in a circus. And some can ask me, well, what the hell does it have to do with the agentic AI? When people look at the horse that is dancing, they think, wow, this is horse, so cool. But actually, most of the job is done by these guys in the background, the ensemble. So you see where I'm coming to. The ensemble tries to match the horse rhythm and movements with their melody, so it looks natural, and horse is just having fun. The agentic AI works relatively the same way, in the way that large language model still just produces the text in plain English based on the prompt. And the actual work is done by AI workflow orchestrator. So the simplified, like really simplified workflow looks like this. We get the prompt from the user, we run the query to a large language model, providing the user prompt and the list of tools that this large language model have access to. So we say this tool can do this and it can take these arguments. Like for internet search, it will be just one search string. There might be some tools that can have, like, if you want to get the weather somewhere, it can have the latitude and longitude as parameters. And then the orchestrator, so the large language model replies with some answer, and the orchestrator checks, do we need to run any tool? And if we need to run any tool, it actually goes and runs the tool. It provides the output of the tool back to large language model, runs this query again, checks the thing again, and repeats until large language model is satisfied that no more tools have to be used and we can provide a final response to our user. But when we're talking about implementation, there is actually the whole spectrum of complexity that we can choose to implement these queries. On the on one side is when we don't need to do much at all. So we can use already existing tools provided by OpenAI, by Anthropic. On the other side of the spectrum, we implement everything in Python or other programming languages. And there are a lot of tool sets that allow you to choose somewhere in between. So we will start with the tool where you don't need to customize much at all. And this is custom GPTs from OpenAI's ChatGPT. Pretty much, you just need to provide open API definition of the tools that it can access, and it runs the whole query by itself. It can use some of the API calls that you allow it to use, so it can access some custom application databases and things like that, and then it gets the final response. So the advantage is it is really simple. So the setup takes like 1 minute. The disadvantage is that all your data has to be externally accessible, because the OpenAPI will call these tools from their IP addresses, from their own AI workflow orchestrator. And it's, well, obviously not as secure, because all the results will go back to OpenAI as well. If we are going to talk about IRIS in this context, I have a sample which I'm not going to show now because we have just 20 minutes. I'm going to show it on the demos and drinks, which all of you should attend. And my team is going to show both of these architectural patterns, let's say. But pretty much here we provide ChatGPT with OpenAPI that can call into IRIS production. And there is a standardized service which can provide access to multiple operations. So here I provide access to my IRIS metrics, list of namespaces, list of users, things like that. And the service is actually, I don't need to modify service when I add or remove some operations. I just do the checkboxes. And my large language model is automatically aware about how to use these operations. So if we look at it at action, this is how we set it up. So we provide the OpenAPI, which is, again, generated automatically by that super service. And then we can query this IRIS agent as just normal ChatGPT window. So it will call our endpoint, ask us to confirm that we actually want to access the server, and provide the answer. And this is what it looks like in terms of messages. So we get, like, give me all the users that have web in its name, and I reply with the list of users in JSON format, and large language model can understand what all this is about. So the next pattern that we can choose is Model Context Protocol from Anthropic, MCP. It is a little bit more complex because now we have to implement the MCP server on our local machine. I have a sample implementation which can talk to our super service, which provides access into the IRIS production. But in addition to that, we can use MCP tools that have access to our file system. We can access our local databases or databases that are behind our firewall, because the server is actually running locally on my laptop now. It's not, the queries to my databases are not coming from Anthropic servers, they're coming from my server. Yeah, and then it's pretty much the same. So we go into production, we grab the data from production, and we return it back into the local instance of Claude, which then will determine if it needs to call something else or not. And this is what it looks like on the user interface. So it will, again, ask our permission to do this call, and it will give us the results. Now, if we want to do something more complex, we can implement the AI workflow orchestrator locally on our local machine in like Python or some other programming language. So here we are actually running the whole workflow locally, and we treat our large language model as just one of the services that this workflow orchestrator can run. My colleagues will show this example of how this can be implemented. You are not limited by just one model. You can call OpenAI for one types of queries, Anthropic for another types of queries, your local instance of Llama or something else for just another type of queries. So it is very powerful, but takes much more time to set up and implement. So please, guys.
Thanks, Sergei. So we're going to do a demo, or rather Reven is probably going to do the demo. I'm going to sort of give you a bit of a rundown on what we're going to demonstrate. So it's an agentic AI workflow. The use case we're using is contract analysis. The use case is not important for this. It's just done for illustrative purposes to demonstrate sort of what a multi-agent workflow can potentially do. So what we've got is a management agent, and then we've got a contract analysis agent that's got a tools, which in this case is going to use InterSystems vector search to search the document. It will compare clauses with the standard clauses, sort of internal standard clauses. Then we've got a risk analyst that can do, it's got a tool that it can do web searches with, and that it can use to search the web for, or compare the industry standard clauses with the non-standard clauses. Then it's got a recommendation consultant, and this will make recommendations based on these risk impacts. And then we've got a bit of a human in the loop with this, where the human, depending on the human, it will then move over to the action planner, and this agent's got tools to access Trello, and then it can add, based on the recommendations from the risk manager or consultant, add those things to Trello. All of this magic, and I think that's for me the big part, is happening inside of IRIS. So embedded Python. We've been using CrewAI, but once again, it's for easy illustration. So it could have been LangChain or Llama Index or any other framework. Over to you, Reven.
All right. Thank you, Herman. Okay, so to recap the use case, we're putting in a contract. We've got a multi-agent team of AI agents that's going to analyze this contract, and on the other side of it, we are getting a list of tasks of things that need to be done that are risk related. So let's break that down and walk through it. So to build this agentic workflow, effectively we need to build agents, tools, and tasks. So looking at the tools that Herman spoke about, we've got things like your IRIS vector search tool. So this searches your vector storage within IRIS. You've got web search tools, and there's a bunch that exist, things like Tavily, Serpdev, etc. So we're using Tavily. And then you've got Trello tools that we've built as well. Now thinking about what's a tool, with CrewAI, it's effectively a Python class that implements a particular interface, and the run method needs to be implemented. That's what gets called by your agent. So if we look at your IRIS vector search tool, effectively we've got a run method and we've got some code in there. So the nice thing about this is sometimes tool calls can get really complicated, and to cater for that, we can have message schemas in Python that actually have descriptions that feed into the agentic system as prompts, so that your agent running the tool knows what data elements need to be passed in for your various different object fields. So this is an example of that in the Trello tools. So moving on to creating agents, we said tools, agents, and tasks. So we give our agents a role, a goal, and a backstory. A role is really the persona we want them to take. The goal is what they're going to do, and the backstory is what type of skills we want them to use in getting to that goal. And when creating our agents, you'll note that we can also allocate or assign different large language models per agent, and different LLMs are stronger or weaker than others depending on the task that you're trying to do. And this is quite a flexible way of saying, okay, this agent needs to write code, let's give it something like Claude Sonnet 4 or Opus or whatever the case might be. The others just doing some summaries, maybe we use an OpenAI model, whatever the case is. So we can assign the LLM, but also here's where we'd assign the tools to these agents. And then once you've created your agents, then we create tasks, and a task is also a prompt where we provide a description and an expected output, and then we assign this to one of the agents that we've created. So once we've got all of these, we can string them together into a crew, and again, we're using CrewAI, but in other frameworks, you would do whatever those frameworks allow you to do. So you might create a graph if you're in LangGraph or etc. Right, so let's look at what that output looks like. Now this is a lot of text, so you don't need to read through all of it. You can just follow along. So the first agent starts off and it reads in our contract. Now just to show you, it's a really simple contract. Here's what the contract actually looks like. And we'd see when we kick off our crew, the first agent reads in this contract, and then it breaks it down into clauses, and it does a vector search for each of these clauses to determine similarity between what we have stored as standard clauses versus what we've got in this particular contract. So we can see what are effectively non-standard clauses. Then the second agent takes this list of non-standard clauses and says, okay, so this is not what we usually do. What kind of risk are we implementing by doing this? I'm going to go search the internet and try to find out. Now, realistically, you're probably not going to do an internet search, but again, this is illustrative of capability and not the use case itself. So the second agent goes off to the internet, comes back with things like what your current wording, what the issue is, risk level, justification, including sources, etc. And once it does, and it does the same thing for each of the clauses, and then once it's done with that, we get to our recommendation consultant, who now has a bunch of information that's based on what our agentic system has found both inside our vector store and on the internet, and it starts to collate all of this. And I'll show you the final output at the end on a Trello card, so it's a bit easier to understand what's actually happened. But effectively, this comes up with the list and then asks for human feedback, and that's your human in the loop. And let's just scroll ahead to that. Whoop. Right, there we go. So it effectively says, please provide feedback on the final result. Now at this point, we can say, I don't like what you've done with clause 4. Here's what I had in mind, or whatever the case might be, and it would rerun that piece of the agentic flow based on the input we've given it. In this case, I just tell it that it looks good, so it moves on to the next step in the process, and that is taking this list of tasks or taking this list of recommendations and talking to Trello to create tasks on your Trello board so that someone can actually action these. And what we see is, so we've given it the Trello tool, and it tries to use a Trello tool and it fails. It says, and it's got some error. But now instead of everything coming to a halt, it tries again. And the second time it's successful. And it basically then goes through everything and then creates a tasks and gives us some links. So let's go look at what that looks like in Trello. Okay, so here's what it's created. And if we open up one of the cards that it's created, we'll see what it's actually done. So in the current contract, the wording says, vendor will use reasonable efforts to make services available to client. Now that's just horrible wording. That's just full of ambiguity. What does that even mean? And the agent says, well, here's an issue. It's vague. Here's a potential impact across financial, operational, and legal. Here's why we think that's the impact, along with a source. And here's the wording we recommend. Sorry, I seem to have clicked on that. Right, and what that means is now, as a human, I can just go onto my Trello board. I've got all of my recommendations. I can work through them, and ideally my contract's going to be in a better space. So that's the demo. I hope you enjoyed that. There's still a lot of things that you need to think about, and having all of this running inside of IRIS helps a great deal, because it allows us to leverage some of the IRIS capabilities like your data management, interoperability, and analytics, and bring them a lot closer to your agentic workflows. And with that, I'm going to say, if you have questions, you can find me outside. You can find Sergei in the demos and drinks, showing you showing you what he's spoken about. And thank you all for joining the last session of the day.